Okay, so next up, we talked about correlational research method. Next up is the partner half, experimental research. People tend to, in everyday usage, call almost any kind of research inquiry experimental research. Hey, did you hear about that experiment they did where they asked people to respond to a survey about their favorite flavor of ice cream? Well, that's not an experiment, that's a survey. So if we are doing almost any kind of data collection that isn't technically an experiment, it's correlational. So surveys and case studies and observations and all that stuff, those are all correlational methods, looking for patterns. But now we want to know cause and effect. So the only way to directly test for cause and effect relationship is through an experiment. It is the only way to test it. Again, knowing that a pattern exists doesn't equate to knowing why the pattern exists. Then let me give you one more example. Our ancestors have known for ever and ever and ever, tens, if not hundreds of thousands of years, where the sun comes up on the horizon, where it goes down at night, what path it's going to take across the sky by season. They know that in the summer, the sun comes up here, it sets over there, and it goes up pretty high, and they know in the winter it goes kind of more this way, and it goes lower. They can predict that. They can measure that. We think that that's part of that is maybe what Stonehenge was about, right? They could measure it. They could predict it. They could see the patterns. What they couldn't tell is why. What was the sun and why did it appear to move across the sky? They could measure it. They could predict it, but they couldn't explain why. So that's how we get stories like Apollo and his sun chariot, right? Well, that must be why it moves across the sky. Here we get to the real why. So this is the only way to test for cause and effect. Now we talked about in correlational, we measure 2 variables per person and then see if there's a pattern. In experimental research, we typically also have 2 variables in the study. All experimental designs must have at minimum 1 independent variable and 1 dependent variable. A lot of experiments are actually a bit more complex and can have more than 1, but you have to have at least 1 of each. So these are still variables, concepts that can take different values that can change. We're looking for cause and effect here. So in a very short way of thinking about it, the independent variable is essentially the cause. The dependent variable is essentially the effect. So unlike correlational where we're going to measure both, we're only going to measure one of these really. So to say it a bit more formally, the independent variable is the variable that the researcher is directly manipulating. It's the variable that the researcher is directly manipulating. So let's say I'm going to run an experiment to see if some new medication will help lower cholesterol levels for a population. Well, I want to know if the medication will cause a change in cholesterol. What I'm directly manipulating is the medication. I'm either saying, hey, take this pill, or no, don't take that pill. That is the independent variable. What's nice in a statistics class is that once we get kind of outside of chapter 1-ish, we don't say independent variable very often. What we often say instead is treatment. So in a statistics class, the independent variable is often called a treatment, and that also can help you try to keep keep it straight in your head, right? If I'm giving you the pill for cholesterol, the pill is the treatment. The pill is the cause. Will it cause a change? It's the thing I'm in control of. Do you get the pill? How much of the pill do you get? The dependent variable, as I mentioned, is the effect. So the dependent variable is the outcome that we measure. So in this example, it would be the cholesterol. I'm going to measure your cholesterol. I'm going to give you a treatment, and then I'm going to measure your cholesterol again to see if it changed. Did the treatment, did the pill cause a change to your cholesterol levels? So the dependent variable is the outcome that we are measuring. cause and effect. It's very important that you be able to tell the difference. Which one is an independent variable, which one is a dependent variable. So let's say I've been doing some reading in the research that's connecting nutrition and intelligence. And out of that research, I devised the idea that, a hypothesis, that orange juice in particular will change intelligence. And I believe that people, based on the reading I've done, making this up, but that the people who drink orange juice will be more intelligent than people that don't. There's something about the nutrients in it. So to test that, I would need to run an experiment. And so I would get a sample together and have them drink orange juice and measure their intelligence and see what happens. So in this very loose generic example, what is the independent variable? What's the cause factor? What's the thing I'm directly in control of? What is the treatment? That would be the orange juice. I'm giving you orange juice to drink or not. It's the cause. Will orange juice cause intelligence to change? And therefore, logically, the dependent variable is intelligence. That's the thing I'm measuring. I measure your intelligence. I give you orange juice. I measure your intelligence. Did it change? So that's the outcome that I measure, is the dependent variable. So breaking it down the way I just described it is one way to approach it. There's a couple other ways of trying to figure it out. So one of the things to think about that can be helpful, it depends on sort of like how the question is worded, if you will, in terms of if we're talking about exams or quizzes or just book examples. The independent variable or the treatment also defines different groups in the study. So if you're trying to figure out, well, which one of these ideas is the independent variable, if you're reading one group drank orange juice and one group did not, well, what's the difference between the groups? Orange juice? Then orange juice is the independent variable. One group took the new medication, the new pill, and the other group did not take the pill. What's the independent variable? The pill. So the independent variable, the treatment, helps to define the differences between the groups. That's one way you might be able to tell the difference. Another way is that cause has to come before effect. You can't have a change in your cholesterol and then I give you the pill and say that the pill caused it, right? That doesn't make any sense. So if we know our variables are intelligence and orange juice, one of the things I can say is, well, the researchers predicted that drinking orange juice would cause intelligence to change. But what if I reverse it? I would say the researchers believe that intelligence will cause orange juice to change. And that just sounds silly, of course. So that can't be it. It's got to be the other way around. The researchers believe the pill will change cholesterol levels, or the researchers believe that cholesterol will change the pills. Again, that second one sounds silly. So if you get them in the correct order, the first one is the cause, orange juice or pills. The second one is the effect, the dependent variable, either intelligence or cholesterol or what are you. So any of those approaches can help you to break down a situation to figure out which is the independent, which is the dependent variable. There are other variables and other things to talk about here that we will continue with in the very next video.